Good morning, class, and welcome to my flight planning and execution project video. My name's Bill Finch, and I will be conducting this short video. So the project methodology. For this project, I conducted a procedural analysis of a recorded G1000 cross-country flight. The purpose of this analysis was to evaluate how the Garmin G1000 navigation system supports waypoint navigation, flight plan management, and situational awareness during execution of a planned route. Screenshots were captured during key phases of flight to analyze system interactions and operational workflow. So, for this flight scenario, the departure was over in Australia at YBMK. The destination was at YBHM. And here is the route string going through. There were several waypoints along the way, and then we did an off-run approach for RNAV to runway 14. The aircraft was a Cessna 172, which is what I'm used to flying. So for the flight plan entry and route configuration, so route entry procedure, selected, so the pilot selected the FPL soft keys to access and activate flight plan. He used the FMS outer knob to select the waypoint field where the letters were going to be. Then he used the inner knob to enter the departure and destination identifiers, verified the waypoint sequencing and leg order, and then confirmed route activation to display a magenta course line. The flight plan management considerations. So waypoints sequenced automatically upon leg completion, the active leg highlighted for situational awareness, and distance and bearing continually updated. And that allowed for modification in flight if necessary. If he wanted to update something while he was flying, he could. So that was pretty neat. Let's see. En route navigation and moving map utilization. So the moving map integration, the real-time aircraft position displayed relative to the programmed route. So it let you know where you were in relation to your route. The magenta course line provided lateral guidance, distance and estimated time to the next waypoint continually updated, and the automatic leg sequencing upon waypoint passage. So as he passed a waypoint, it automatically went on to the next one, which is really nice. Situational awareness enhancements. So a visual depiction of surrounding terrain. Down here on the map, you can see all the islands and stuff that were around him as he was flying. The ability to adjust map range for strategic or tactical awareness. Immediate cross-track air feedback as the wind's blowing you off course or whatever. It lets you know, hey, you're drifting a little bit, come back over here. Reduce the need for mental dead reckoning calculations. So instead of, having to worry about exactly where you were and staying on that flight path, you just got this little guy right here that helps you stay on, and the little thing in the center, if it starts drifting, you just adjust to keep it centered. So that's really useful. Approach selection and activation. So when he was programming, he selected the procedure soft key, selected the approach, selected the RNAV for runway 14, and then chose the AVIA transition, which you can kind of see right here in the picture. It's like a loop that goes up like that. And then he chose the AVIA transition, loaded it into the active flight plan, which is pretty easy. And then so load allows you to review it before activation, and then activate immediately sequences it into the initial fix. Automatic leg sequencing reduces pilot workload. And final approach course depiction on the moving map. So it automatically goes on to the next leg as you pass it, and then it also assisted on the final approach by depicting the elevation that you needed to be at, and showing on the moving map what was going on. So some of my observations for this. So the advantages were the integrated lateral and vertical guidance that reduced the pilot workload, clear magenta course depictions that improved course tracking precision, automatic leg sequencing, which minimized head downtime, real-time distance and ground speed data, which supports good decision making. And all those are, positives that are really cool. I did notice a couple things. So for limitations, the knob-driven interface might increase workload during high-demand phases of flight. But I still think it's designed really well. The menu depth could slow rapid route modifications if you got redirected and need to put it into the MFD, and you're busy workflow, you have to hurry up and try and get it over there, going in several things to change that. Sometimes that might be a limitation, but all in all, I think it's designed really well. And then just the overall potential for over-reliance on automation. You still need to make sure that you're maintaining good pilotage and being a good aviator as you're up there, not just relying on the machine. So this is my reference. This was the video that I watched and made my analysis of on YouTube. I've got some final remarks here. So this analysis shows that the G1000 is more than just a navigation display. It is a fully integrated decision supporting system, from flight plan sequencing to moving map awareness and approach management. It significantly improves information flow to the pilot. At the same time, it reinforces that automation does not replace responsibility. Understanding how and when to use the system effectively is what truly enhances safety. Thank you.